Hey everybody, this is Larry. This is me doing an extra problem for today because the weekly problem was already done. Usually I do an RNG, but I'm going to try something a little bit different today, which is that, well, still going to try to do a problem I haven't done yet, but I'm going to just go do these problems backwards, just because, I don't know, because I think there are fewer people who have done it. I don't know. Let me know in the comments if this is good. Maybe I'll try it for a week and then see what happens. But yeah, let's take a look. Today we have 3155, maximum number of upgradable servers. It's a medium problem. You have n data centers and need to upgrade their servers. You're given 4 arrays: count, upgrade, sell, and money of length n, which shows the number of servers, the cost of upgrading a single server, the money you get by selling a server, the money you initially have for each data center respectively. And you know what that means. You have to hit the like button and the subscribe button and join me on Discord because I don't know. Look, I don't sell anything, and also don't give me money, because it's probably a scam, or like maybe you could give me money, but if someone asks you for money and it pretending to be me, it's probably a scam though. In any case, I don't know. My point is that this YouTube's is all for free as far as I can tell. So this is the only ad I get. Return an array answer where each data center, for each data center, the corresponding element represents the maximum number of servers that could be upgraded. Note that the money from one data center cannot be used for another data center. Okay, we read the problem together, but I have not actually absorbed the problem. So okay, so you're given like a. Okay, so you have all these data centers. You have number of them, the cost upgrade, the money you get by selling it, the money you initially have. And you're trying to maximum number of servers that can be upgraded. Okay. Does the data center matter? Okay. The money from one. Okay, well. So if why is this a note? This should just be like in the problem. This is so weird. It's like, note, you actually need to read this. It is not a note. This is part of the problem. What? Like what? Okay. In any case, yeah, so it seems like in a weird way. I mean, everything is 10 to the fifth, so okay, so we have to be a little bit smart maybe. But the thing is that it doesn't even matter. Yeah, I mean, it doesn't even, like, there's no, like, the data centers don't affect each other, so basically, essentially, you're given n inputs, really, right? So CUSM, luckily that doesn't spell anything nasty. In SIP of count, upgrade, sell, money. Okay, what are we doing? And then, oops, how many servers we can upgrade? Okay, so we just kind of solve it one at a time. And okay, so we have 4 servers, and the numbers can go up to 10 to the 5th. I mean, I'm guessing. I mean, I have to figure out. This is like intuitively. It's either there's a formula and we have to figure it out, or we binary search. This is my thought right now. Let me finish reading it. Okay, so you have the number of servers. So you have C servers. You can upgrade a single server by buying U, the money you get by selling a server, and then the money that you initially have. Okay. So you want to see how many upgrades you can get. Okay. So then now, initially, you have M. So you can always do this, because basically this is base, right? Because why wouldn't you use the money that you have? You can't keep it, right? So we always do this. Yeah, we always do this. And then now we have M, we mod it by U, right? And we also, well, not yet. Okay, let's upgrade it is equal to this first, right? And then now total upgraded, M we can do it by U, but then now we also want count to be subtracted by upgraded, because you can't sell. Yeah, I don't think there's any case, and I could be wrong, where you upgrade it. And that would be a really fun thing if we upgrade and then sell. But that just seems silly. Though it is technically possible. But I mean, it should be like how many that you upgraded and kept. if you really want to be pedantic, but I don't know. I mean, maybe that is actually a trick case, and that'll be a funny thing. I'll be like, well, they kind of, wrote something weird. But okay, that means that we can upgrade at most C times, or, but yeah, if you can upgrade the money that you have, I don't see any reason why you would sell to get more money and then upgrade it anyway, because the money is fungible. Okay, so then now we have, I guess C is actually, or this is a little bit wrong, because this is actually minimum of this or C, right? And then now, okay, then M is going to be subtracted by upgraded times, I mean, I don't think this matters, but it's a little bit more precise, right? And then now, okay, yeah. Okay, then now this is good. And then now you have C, U, and okay, so then you have money, you have the cost of upgrading one, and then you sell a server. Okay, so then now what is the formula of that we're trying to maximize, right? This part is a little bit tricky for me anyway, because it's just a lot of things to keep track of. But then now M plus, okay, let's do, instead of trying to be too clever, let's do a little bit more naive, right? Let's say we have a folder, but we don't. We upgrade, or we sell I, so it's going to be money plus I times S divided by U, right? So it's going to be min of this, or I mean, obviously you can only get and then C minus I, right? So this is the formula that we have, and obviously also that I has to be less than C. So with the constraint that I is less than C, right? Wait, what am I doing here? Oh, yeah. Okay, well, the first thing that we can do is if we try to minimize this function, right? Because then we could times U on both sides, right? Because U is positive and also it's a constant, so it's fine. So then now we have the minimization of this, right? Where C is I is less than or greater than C, and of course the definition changes a little bit. So instead of, yeah, so because this is now the money that you get, and this is the money that you need to upgrade everything that you have, right? And then it's just this thing divided by U is going to be the answer. Yeah, right? And then now we have to minimize this. Man, I am not good enough for this. But okay. But then now we can kind of separate out the constants, right? So then that means that the times U is here, and then now you have min of these two things. But and I in both cases has to be less than C, right? Is that the way to do it? I don't know. I'm not very good at this. Is this a thing we saw with ternary search? I mean, we probably can, but I'm just a little bit lazy, to be honest. Let me think. Or like, I'm just trying to I'm trying to think whether there's a more fundamental, like, obvious way to do it, and it may not be that it's not the case, right? like some people who are very smart at math could do it. It seems like, but I don't know. But basically this function will be the minimization is going to have like a curve, right? Well, no. We're trying to maximize. So you have this function. It's going, and we're trying to maximize that curve, and that curve is going to. So, like, if you want to think about this, this is just a line. This is also just a line, right? So yeah. So you have two lines, and then the min function is just the min of these two numbers. So then it's going to be like a. Oh yeah. Then the slope of this. What is the slope of this line? Well, it's going to be I because I is the variable. Well, no. I is the variable. So the slope is going to be S. This slope is going to be U. And I'm sure, so it's going to be a thing like this. So then you can do a ternary search for sure, right? Because then the minimization of two lines, one with S, which is a positive slope, and then a negative U, which is a negative slope. So you have something like this, right? And then, I mean, when they cross, and then you have the min of it, so it's going to look like a pyramid. So you could climb. I mean, that seems like a very basic ternary search. And of course, because I is discrete, you can also use binary search. But I don't like doing that because it just feels yucky from a numerical analysis thing. So I'm going to use ternary search. It's a good practice for me to do that anyway, right? So yeah. Okay. I kind of knew that I could have done it anyway, right? But I just wanted a stronger foundation. It's something that I know and understand, but it's just not something that I use very often, to be frank. Using the ternary search, and here, yeah. Once I kind of go back to the basics, right? I mean, some of this stuff, if you have, like fifth grade or sixth grade math, you probably know, like the slope and this, this is a line and this, but. And I is the variable that we're trying to optimize. But and you could probably actually solve for this because I guess actually, yeah. Wait, maybe I don't have to. Wait, hang on. Because when we're trying to maximize this function for over I, then that means that this min, as we said, because this has this slope and this has this slope, so they meet somewhere. We can still use ternary search, but actually it means that if this is equal to this, then that is basically the peak of this intersection, right? So we can try thinking about that way, which is that m plus I times s is equal to, let's rewrite it as, maybe not, because these are all constants, right? So then now we add I on both sides, right? And subtract m. And then now we have I times s plus u, right? So I is going to be, okay, fine. Let me just write it out. And then now, obviously, we divide okay, is that right? Yeah, I think that is because you have two lines that intersect, and that's going to be your thing, right? Okay. I mean, we'll try, and maybe it's off by 1 or something like this, but we'll at least try it. Yeah. And then this is going to be the I, right? Yeah. We can set I is equal to this. I just want to print it out real quick just to kind of play around with it. Or just kind of see what it looks like just in case I'm like really off for some reason. Oh, what are we returning? Oh, we have to do it per server. Okay. I mean, it doesn't matter. I'm just trying to do the print statement real quick. Total. Oh yeah. Whoops. Okay. So 5/7, is that right? What does this number mean? That means that if we plug it back in here, in theory, we should get the min, right? So then now, or that's the um, that's the number of, well, this is the money that we get, and then over U is going to be the thing, right? Is that right? This is the money that we get. I guess so. We have 4 units of money, and I don't know if this is right. For the second case, we have 5.7 units of money. That's not quite right. Well, what is I again? Well, I think one thing that I might have messed up on is the, yeah, no, that's fine. I is less than C. I think that was the constraint that we have, but I didn't check for. Why is this 5.7? What does this mean? That means the money that we have, because then now this over U is supposed to be the number of servers. I mean, I'm dealing with fractions because, or not, because I just want to see. Oh, is this, but no, we already add M. So this is saying that we can sell 5, which is a little bit of an awkward thing, to be honest. We get this money, and we also start with M, right? Okay, let's also, what M do, what's M again? So this is very weird because, oh no, because we still by U. Okay, so we get 1.4 new servers. But okay, I guess maybe this is a little bit easier to see. So we already upgraded 2, and then this gives us an extra 1, right? This gives us an extra 1. Yeah, I guess. I mean, I think this is right, but it's a little bit scary. Okay, so this is the number that we sell, and we can, and that's the thing is, oh no, you have to round down. I guess it doesn't matter whether we round up or down, because I think I'm gonna round down, but I think it doesn't matter because if you sell an extra 1, that means that on the other side of the thing it's going to be whatever, right? So that's going to be the min, maybe. So that's the money, or that's the number of servers we want to sell, and this is the number of things that we're going to buy, and then yeah, so then now we add total to this. Oh, huh. Why? Tell me why. Because I is 0. So this is returning 0. Well, yeah, because it's 0.57 whatever, right? Why does that? They intersect there. I'm trying to, I mean, I know that there are a couple of tricks that I can do to fix this to get an AC, or at least closer to an AC, but I'm trying to understand the underlying things about it. That's why I'm taking some time. So please bear with me. This is actually a good problem. I like it, or I like that I'm doing it now versus whatever. And then maybe like during a contest, right? If I'm spending a lot of time during contests, then you know that's a different thing. And this is stuff that I am not as good about, so I think is yeah. Hmm. Okay, so you have C. You have 2 servers left because we spent. How many did we upgrade it? We upgraded 2. So that means that we have $2 left. Okay, yeah, that's true. Okay, so I have $2 left. If we sell 1, we get $4. How does this intersect? Why is this wrong? Okay. If this is 0, let's look at this formula then, right? So for I is equal to 0, we have 0 plus 2, so you have min of you have min of 2 on the left side, and then 0, this is going to be what's it? What is C times U? We have 2 more servers left to upgrade to 2 times U, which is 3, so this is 6, right? Okay. And then now I is equal to 1. What do we have? We have min of this is 1 times 4 plus 2 is going to be 6, and then 1 is going to be yeah, what is U again? U is 3, so minus 3. Wait, did I do this other part wrong? What is this? C is, well, it's going to C minus I times U, so that's going to be 2 minus 1. 1 times U is going to be 3. So then this is actually 3, right? And the reason why we get 5/7 or 0.57 or whatever is that all right, this one I'm just going to use a calculator. Right. Times 4 plus 2 is going to be 4.28-ish. I mean, I know that, oops, it's slightly rounding, whatever, but I guess it makes sense, right? Because this goes up and then this goes down, right? Like we said, the slope thing. So I guess the, okay. I mean, I guess this is what, yeah, okay. I mean, yeah. I mean, I think I just wanted to be clear on the foundations of it. Let me just fill out the math then. So it's going to be 2 minus 0.57 times U, which is 3. It's going to be 4.29. I mean, yeah, like there are more digits that makes them the same, so it's going to be the same here. Okay. I don't know if I need to round this, or like maybe rounding is the good way to do it. But the reason why I think is that what I would do is just proof, because we have we want a discrete I for obvious reasons, so we just try both of them, right? So yeah, so yeah. So then now, okay. So this is going to be the round down, and then we also try round up, right? So then we have I plus 1. So then we just have to basically look at the maximization of this, right? So if so I'm just double checking my, or I'm just a little bit lazy about coding this. Okay, fine. Plus I times S, S times, and this will always be, I think the way that we structure the rounding down, this will, and this, given the slope, you actually don't need this min. This part is always going to be the smaller part. But yeah, is Okay, let's just j is equal to I plus 1, right? So then now if this is less than, and again the other part is going to be for the same reason because of how we structured the rounding up. It should be that this is always going to be bigger than this, but I'm too lazy to, or maybe we'll optimize it after we submit, but I'd rather get it right for now, right? So then now here, j is the answer, right? I is equal to j, so that we can fit the rest in here. I'm a little bit lazy. And then that's it, right? Oops. How did I miss clicking that so many times? Okay, still wrong, which is not great. Why is that? Because I just CMI, so that's 3, right? Oh, I is the number we're selling, and this number. Oh, well, yeah. Now we need the min because here we're limited by this side, not that side. Okay. Right. Huh. Tell me why. Oh, I'm just being dumb because, yeah, the U has to go on the outside. Okay. All right. Let's give it a submit. It's a little bit wonky in logic. I'm not. I mean, we'll give it a submit. I'm a little bit like I feel like I should have done better on the logic, but it's okay. And here we have some, well, silly mistakes. So let's take a look as to what happened. So it is wrong for this case. These are just so annoying to debug. So it's the fourth case, which is 1, 2, 2, 6. So we'll just kind of separate them out because it doesn't even matter. Right? Yeah, so 2 and 1, right? Why is that? Let's take a look. Oh, because we have negative. So that was the thing that we have the I is less than C thing that I was talking about. So I could really, I is -1 is definitely not what we want, right? So yeah, so we can check that. Yeah, I mean that's just a silly mistake. CI, so we don't sell. I mean, we sell all of them. It shouldn't give us a weird answer, but in any case, yeah. And also we want to make sure it's at least 0 for obvious reasons, because yeah, okay. But a little bit of a. I mean that I was thinking about that case, but I think I was just too focused on the other things to figure it out. And yeah, not so bad. I mean, this was definitely trickier, and I think if I was stronger on the maths, because I think, to be honest, right, like if you're watching and you'll be stronger at the maths, all this logic probably falls very clearly. I was just a little bit. I spent a lot of time trying to, do everything from first principles and trying very hard not to skip things, right? Like I can make some. Like I was on the right track, but I want to make sure that going from A to B, like I knew that going from A to, or I was relatively confident that going from A to B is correct, but I want to understand the steps in my head, and that's basically So then next time I see something similar, I could be more confident, right? Okay, so let's clean this up real quick. Yeah, I mean that wasn't so bad, right? Okay, let's give it a submit again, right? Just to kind of have that up in there. And now, as we said, this should be on the I side, right? And this should be on the max side. So then now we can do this, and we can submit. Should be a lot faster because we get rid of a lot of min functions. I guess there's not that many inputs or something because we don't really do that many things. I mean, there's a couple of things we can have cleaned up, maybe even like here, but I'm not really that worried about it or care about it. Yeah. I mean, okay. So what is this? This is linear time, linear space, right? For pretty obvious reasons. We just have a loop and one formula on each loop. I actually don't know why this so like why it takes 2 seconds. Is there like well, 574 cases where each of these has like 10 to the 5th number of inputs, which is a lot. But you know, we can clean up slightly, but it's fine. And I don't even think we need to do the upgraded thing first. We probably could have just skipped it and it'll give us the same answer. I am curious about that, so let's play that around. Because I think it just shifts the numbers, right? So I think that should be good. But I wanted to kind of do the logic thing one by one. So, and we don't even save that much time. But yeah. Let me add a note to myself. No, it's fine. I have this video, so I guess I can just watch myself. Alright, I don't know why I submitted 5 times on this one, but I just want to kind of, have it for the future. Because I actually, I mean, I think this is a good enough problem. I think for me, it's just about relearning things that I'm a little bit weaker at and haven't really explored in a while. So for me, I don't know if I would say this is a good problem, but it's a good practice problem for sure. That's all I have for today. That's all I have for this one. It took way longer than I expected because I suck at math, as you can see. Because I think it's just very mathy. Yeah, like you can do binary search, but I mean, I knew that you could do binary search. I knew that you could do ternary search, right? But I just wanted to, especially now that, like, I'm pretty sure during a contest I would do a ternary search. Not gonna lie, but I was trying to be a little bit smarter, and I kind of saw how I could be smarter. So it wasn't like if I was stuck, even in practice, maybe I'll just do ternary search. But here, you could see that they're linear functions, so it really should be solvable, and that's basically what we did. All right, that's all I have for this one. Let me know what you think. Thanks for watching. It's a long video. If you watched to the end, let me know if you're gonna watch Deadpool 3. I'll give you props in the next video if you leave a comment about it. But yeah, stay good, stay healthy, do good mental health. I'll see y'all later and take care. Bye-bye.